So thank you very much. Look, just to say at the beginning, I'm quite informal about the way that I will do this. So if you want to interrupt me or if I'm not making any sense, please shout out, and I'm happy to take questions throughout at any time. So as Will said, I am the founding director of Useful Studio, which is an architectural practice, and we've done this project with Expedition Engineering, who are civil and structural engineers who've been around for about 20 years. We exist under the umbrella of the Useful Simple Trust. We are 5 different brands: engineering, communication, sustainability, an education outfit, and then architecture. The thinking behind that was that we all have a sort of interest in the synergy across the disciplines, and we appreciate the agility of being in one space, about 80 people in one studio, working very closely. And of course a bridge is the ultimate synergy of disciplines, and a real rigor required in the communication between the different disciplines working to get the best solution in bridges. As I say, Expedition, they work on very high-profile projects with, this is the Athens Opera House with Renzo Piano, Hopkins Velodrome, and this is just Selfridges, which has recently opened, a David Chipperfield scheme, a really super complicated cut and carve where they had to prop up the building but not let a single shoe teeter on the display case within an operating shop. So a very, very complicated project. And so they do a combination of high profile but also behind the scenes challenging structural and civil engineering, whereas the studio has only been going for a few years, much more modest. A lot of work in education, master planning, getting access to funds for schools, and doing refurbishment. And I think probably the thing that we're most busy in is repurposing buildings. There's a lot of work in London in that, and it's really quite fun. And that's where having engineers in-house with me is very helpful, because you can all work together in problem solving. So we have a history, as Will said, of doing bridges, and the Millennium Bridge really probably almost before your time. 20 years ago, we did the competition, myself with the founding directors of Expedition while I was working for Foster's, and then went on to win that and build it. And lots of lessons learned really throughout the project, but also, of course, when it wobbled on the opening day, which was a real eye-opener in terms of never say never about the behavior of a bridge. They're like little creatures, really. Never quite sure what they're going to do. We went on to do this bridge in Stockton as the Expedition studio practice since that time. And so this is an aerial of the Chiswick Bridge that we'll be talking about today. And as Will said, this is Chiswick Park on the left. The red line of the footbridge, it's crossing between Ealing and Hounslow, so the challenges of 2 local authorities and the negotiations with those. Also the Gunnersby Triangle, which is a much loved nature reserve. And then, oh, sorry, I wanted my red gadget, this big residential development, which was built in the life of this project. And the thing that I'll speak about is that it's actually been going for 15 years, the negotiations over this footbridge, and now finally due to be finished in the next couple of months. So long, complicated process. And what it is it's the outcome of a Section 106, which is an agreement which the owners of Chiswick Park entered into, where they promised, in effect, to produce this bridge before the end of their development. So it was reliant on building 8, which is right at the top end of the park, one of the largest buildings there. They can't let this building until this footbridge is in operation and available for public use. So the 15 years, they were aware of this, but they sort of put it off as much as they could, right up until the final window when Building 8 was built. And right now they've got to get their act together with this bridge. And it's sort of a touch and go whether it was ever going to happen. And so the character of Chiswick Park is really, it's quite, well, it's got a fantastic landscape spine down the middle and all these buildings in a Richard Rogers style. The aesthetic is very distinct and continuous throughout, very stainless steel and crisp and tech. And we were aware of this when we were generating the scheme for Chiswick Park, and how you sit in the context of all those very precise buildings with your footbridge. So that informed the aesthetic. The other side is this very white, sinewy ribbon residential development, and this is with the abutment sort of sitting here waiting for a footbridge to cross a railway, as well as adjacent to a London Underground line at the top end of Gunnersby Triangle. So there's the railway, Network Rail, 24-hour operation of this railway line, and London Underground there that we scoot along the edge of. That's the residential line, and Chiswick Park. We also had a road with a very active bus network on it and a car park to cross. So couldn't, very complicated. The only thing we're lacking is water. So we had every other context that we had to get across in the development of this bridge. And the reason why this crane is really important is it's the largest mobile crane in the world. This is the first time one of these cranes was used in the UK. And it not only has to remain stable and lift enormous weights, but it then has to drive around, which is quite a unique challenge for a crane. And we were very pleased to be the first need of this in the UK. And it took a week to build and then another week to take apart again before it moved off to somewhere else. And it was required because this bridge had to be fully assembled on the side and lifted in one piece, fully built, because what you require when working with a network rail is something called a possession, where you basically pay for a window when the railway is closed, huge sums, hundreds of thousands of pounds for 24 hours. You book it in about 18 months in advance. Everything is geared toward this lift. And then this crane has got to do exactly what it's meant to do, and it's all pre-programmed. Its lift and its swing is all pre-programmed with computers. You've got backup drivers in case somebody has a heart attack or faints. So this all logistics are driving toward that, including the design of the bridge itself. This is it, going into position at dawn in the summertime. So everyone very huge sigh of relief when this primary span went in over Network Rail. So that was the ultimate goal, and now I'm going to sort of pick the bridge apart and explain why it is what it is. But just to touch on the history, as I say, it started in 2003. We first started working on this project. And at that time, it was quite a different scheme. The client was Stanhope, who owned the park at that time, not Blackstone, who are the current owners. And the industry was different in terms of views about material use and sustainability. So the bridge at this time was actually entirely built out of stainless steel. And was a very low slung structure, which meant it was working quite hard. Arches are much more efficient than low trusses. And when we were in this sort of course of history, the bridge stopped really because the building stopped on the Chiswick Park site. And when it revived again, this is the stainless steel bridge, we thought, hang on a minute, here's an opportunity to revisit what we were thinking about. And is a stainless steel circular truss actually appropriate? And should we rethink? And as a business, we've been very involved in something called MAECOM, which is minimizing energy in construction, as well as something called MAGIC. And these are sort of professional pursuits around how to use less material in construction, whether it's architecture or any of the industries associated, but in structures particularly, there is a lot of evidence to suggest that things are very often over-structured, to be over-safe or to have a sort of load of disaster built into them, which means things are unnecessarily heavy, which means the foundations are unnecessarily heavy, the shifting around of materials is unnecessary. So there's a sort of pursuit for paring back. And that happened in parallel. So when we came back to this, we thought, right, here we are, quite inefficient, and we could actually be much more efficient if we were an arch. And we looked at quite a lot of detail at the embodied energy of the different weights, and you can see things getting more and more efficient and requiring less and less material as you go into the arches versus the trusses. So then in 2012, this concept emerged. We were then moving from Stanhope to Blackstone, who were quite pleased to have their own design of the bridge, and said, right, let's scrap the old one and pursue this one, especially if it's going to weigh less and potentially cost less and be easier to build. So then this diagram then needed to be thought through. And I should say there are three key spans, really, because we had to think about the three lifts, all being driven by this primary one here. I can use my gadget. This is the Network Rail line, and being mindful of that limited lift. So one contained span there, a footprint just on this side of the railway, another jump over the car park, and then another jump to get to this existing podium here at Chiswick Park. So we have to run right up against this building. So we've made a series of steps, and this one is the longest span, the highest arch, and it was a little bit of a journey in the changing character. Here we're mindful that we're in front of a building and not wanting to be too majestic in taking away the views of the occupiers of that building. So the same solution changes in character, and I'll speak a bit more about this little eyelid here on this bridge, which is very specific to Network Rail. We inherited a series of constraints, which is typical of bridges. As I say, we have to get over the railway. We need to get over this road. There were some existing foundations which were built quite early on in the life of Chiswick Bridge, and then the podium was sitting there waiting for us for these 15 years. And we went then, having considered an arch, this was then when we went into intense analysis of how to pare back the arch. So not just any old arch. We wanted to use corten, which has very interesting characteristics in terms of maintenance, which I'll speak about in a minute. But how can we get the finest, slimmest arch ever achieved? And this is because while bridges are, I spoke with someone in the beginning about, they're just another version of having to span like a floor plate. The thing about bridges is you really do want to be super pared back in terms of material. And you need to really last for a very long time. A typical life for a building is 35 years. For a footbridge, it's 125 years. So you've got to be thinking, how can this thing survive with very little maintenance? It's a piece of public infrastructure, so we'll probably take a beating, and it must be there in 125 years. And you then have to demonstrate this to all the interested parties and stakeholders in Network Rail, and you have something called a Category 3 check. So a bridge, it isn't enough that you engineer the bridge yourself. They then employ a completely independent set of engineers to review everything you've said. So this sort of rigor becomes much more significant alongside our interest in paring back materials as much as possible. So the arch is actually a cruciform shape. It starts quite wide at the base with a sort of flat spine, and then as it goes up to its primary apex, it's a very tall spine with an almost negligible flat portion of the cruciform. So it changes its geometry, and it's across the bottom here in that character. That's directly related to the way that the arch is working in terms of its force, whether it wants to do this or it wants to be that. So this is all in this pursuit of paring back. So rather than just a big box section, it's actually a skeletal arch. So corten, again, it's an American brand for weathering steel, which is that very distinct orange looking steel. And the beauty of corten is that it starts off, it comes out of the shop, and it did for us, the plates were delivered to site looking totally gray. And within a matter of hours, it begins to form its own inherent rust. And that rust protects the steel from any sort of degradation. So it's a sort of natural seal, and it has that orange character, and even if you scratch it, it reforms itself this protective coat. And what that means critically for bridges is it doesn't require any painting. So these sorts of things you can imagine built, trying to get back there and paint that and inspect it for corrosion in the connections, virtually impossible or very, very difficult and challenging. And when you're over Network Rail, you don't even have that option. You can't afford to have a possession of £100,000 every time you want to go and inspect the bolts and do a quick paint. So this thing had to be absolutely self-maintaining, hence the desire to use corten steel. And it's not only, again, this goes back to my point about the Rogers scheme, very, very crisp and aluminium and stainless, and us wanting to be distinct. We would never be able to get the bridge to be as pristine as their beautiful cladding and stainless steel. So let's choose actively to be something different in character. And there is we do have a lovely engagement with the landscape at the top of the triangle, so it begins to take that character rather than that of Chiswick Park. And these are some images inside the triangle, very natural and wild. And this is the animal beginning to be formed as a concept with the primary structure in corten, as I described, jumping over the Gunnersby Triangle in that image and into Chiswick Park. That's the building which cannot be let until this bridge is in operation. So it's sitting there fully assembled and empty at the moment. And you can imagine the money lost while they wait for this bridge to come to life. And it has already, as I say, it's taken on this beautiful orange quality, which is really very distinct. And we had to do a lot of views, actually. It does exist here. I just show this because this is an example of the interest of stakeholders. The Gunnersby Triangle interest group were very anxious that this bridge not be too dominant when they were in their landscape. There's a lot of bats who live in this triangle, and they were very worried about the impact this bridge may have on their well-being. So all those sorts of concerns had to be managed. So some other things that happened over the life, we didn't actually go to a corten deck in the first instance. We started with a concrete deck, and I think probably this is typical of designers. If the longer time you have, the more you feel you can tweak things. So we had this 15 years, it stopped and started. We moved to corten, and then we had concrete. We thought actually concrete's not as environmentally friendly as it could, and we've already got steel, so we started with concrete, and then had a review and went to corten. So, and really this weighs even less because we were able to cut out all the weight, which is that forms the depth of that slab, to get it to be self-spanning across the 2.5 meters. It's now a series of plates. So the deck itself is literally just a single plate of steel with a series of stiffeners. So super thin, stiffening edge, and then timber, which is self-spanning itself, hardwood sitting on the top and upright. So trying to pare it back to the minimum amount of materials and the minimal palette of materials as well, and all things that last forever, really. We look to the Stockton Bridge as a sort of precedent for how we'd achieved this before, and how it can have a much less impact on the eye line, really, mindful of people's views, and again, the people in Gunnersby Park, paring it back. So that's that diagram. The drainage, so it's self-draining the deck, the water goes through, the bridge is on a continuous camber, so it drops through the holes in the deck and then flows to either side and then off. You have to be able to manage any water that this thing collects. Can't just dump it onto Network Rail or onto people's cars in the car park. All has to be collected and then channeled down at either end, the whole quantity of rainwater on the bridge. So things like that, you're then integrating civils, you've got rainwater experts, you've got to be sure you've got a walkway that you can walk on, structures, all those guys working together in the same interest. This begins to pick up what this material palette is. So here's this plate, the corten plate, set with spanning hardwood deck. This, being mindful, it can't be softwood if it's got to survive 125 years. And then all other materials which make up the balustrade system are stainless steel. Again, something which is self-weathering, isn't prone to corrosion, very tough, and has a very long life. Even the infill between the uprights is also a mesh comprised of stainless steel. So three materials, and that's it. This is a mock-up. So to be sure that the interfaces were really to help us resolve the interfaces, we built a one-to-one mock-up. You can see the profile of the corten, the beginnings of these stiffening fins, checking the welds, checking what the character is of the underside, and then how to get, in the simplest fashion, the build-up of the timber and the fixing of the uprights. And this is really a lesson. Again, we did a lot of research leading up to the Millennium Bridge, and that's a much longer bridge, 3 times as long, and it doesn't benefit from the same surveillance. But bridges take a real kicking. People are just prone to sort of shaking them around and kicking them about, and you have to be, and they also steal things. A lot of them have had many of their light fittings stolen. So you have to be mindful of what can look, if it can, look better over time, but withstand that sort of hard work and still have a level of elegance. And it's trying to work that through, having special fixings which can't be undone, and also trying to dissuade people from climbing out on the side and doing things which are a bit mad. And I still see, to this day, I cross the Millennium Bridge and I see people's footprints on the cables. You know how the cables go out to the side over the Thames. So whatever you do, people will still go out and walk along on those cables, which is mad. And you can see the footprints because they've got protective paint on the cables, and it leaves the impression of those shoes. So whatever you do, I mean, so you can only go so far, but if you can try and dissuade people from doing that in your design, that's also helpful. So this is what the underside looks like. It's now, the 3 spans are in position, but you can see the sort of skeletal belly to the bridge, and it really sort of hits home just how unbelievably slender and light this thing is. There isn't a single piece of extra steel, really. We've been very rigorous, and it's taken a lot of modeling and a lot of convincing. And in fact, Severfield, who have built the bridge for us, were not convinced that it would work. So when they inherited the scheme, they then did their own version of a Category 3 check to convince themselves that it was actually going to be possible, this engineering. And it has given you this really lovely soffit that you now experience in the car park and in the road, and this lovely cruciform detailing. And it's really the sort of getting the guys building the bridge, guys and girls, to sort of love the welds and take as much care in the fabrication of this thing, and be mindful of the delicacy that needs to be maintained if possible. So another thing that changed over the life, and this is very critical to the bridge dynamics, is that the cables changed. So we started with vertical hangers like we're on the Stockton Bridge, but throughout the course of testing the dynamics, which we're now quite aware of, having survived the Millennium Bridge, we began to experiment with cross cables, and this is actually called a network arch. These are very rare. People don't tend to do them. I think there's a couple other instances in the UK of this type of arch, because the cables are working very much in conjunction with the arc and the deck. I should say the deck has structural stiffness in it, so that's why those little blades are in it. It's not to carry people's weight, but to give the deck enough stiffness to hold it out and to hold the arch out at the ends and to hold these spreader angles of cables. And it takes a lot of analysis and a real rigor in the design process to get this to work. But what we found was that we hope, although I never say never, the conversion from a vertical cable to a cross-network cable means that we do not require dampers. The bridge is super stable and steady and very, very tightly tied together through the character of this network of cables. And this is a built condition of the top of that arch. Again, you can see this pushing the hole in the arch all the way to the top as much as we can. It comes up as two legs, joins and kisses at the middle, and then back down into two. Again, paring back every piece of material. It probably started down here, and nibble, right until the very end for minimal steel. And here's a visualization, but looks very much like that in life, of these two kissing members dropping down again. You can see the cruciform profile changing in its character, and in this mesh sort of lattice that surrounds you as you go. So that comes down either side. The cables are 16 millimeter in diameter. And this is again something which this bridge shares with the Millennium Bridge. These aren't a spun cable. They are a locked coil cable. It's a much stronger cable, super dense. If you look at the cross section of a spun cable, there's a lot of fresh air in the cross section of that cable. These very strong and effective for achieving that super stiff arch that I described for the design. These little members, which exist every time the cables cross, are also significant. It's lovely. You get to engage. These are built by an Italian outfit who do all the work for the ski lifts. And they're sort of masters in managing little beautiful bits of jewelry almost associated with ski chalets lifts. But what these do is they stop the cables from rattling. And then if they start jangling against, I don't know if you've ever been to a yacht club and you can hear all the sort of stays jangling against each other. We were mindful of the noise, but also the fatigue that might put the cables into if they're constantly shaking against each other. So these little things had to be custom made for every junction in the cable, in which you can see, of which there are many as they go across the network. And in fact, surprisingly, this is where things are, you sort of learn as you go. They are adding an additional level of strength to that network, which forms the tight, stiff arch. So just a little bit on dynamics. I nicked this because they blew this up in the Harry Potter film, which was not what actually happened, thankfully, just a film. But as I say, that we did have to go back and retrofit these dampers to the underside of the soffit. Two different types of dampers, actually. These are mass dampers as well as viscous dampers that we had to put in. So quite a lot of retrofit work to get the Millennium Bridge to calm down. There's those cables that people walk along, which I was describing. Mad. And also we had to integrate them into the bridge in Stockton. But in this instance, we had built them into the underside of this bridge, but will not install them. We have put in, being future-proofing, the ability to add them should they become necessary. So now I'm going to move on to the deck. I spoke a bit about the timber. I was sort of trying to work through the different materials. What we wanted here was for the timber to be not just a finish, but to add another level of importance in the makeup of the bridge. So its weight is quite important. Hardwood is super dense. So it then adds to the ability to settle the bridge down. Not enough, again, it's this fine balance between what you want to lift up and move over a railway with a huge crane, but at the same time be beneficial. It has a very long life. It's self-oiling. It looks after itself. It weathers to a natural grey. It spans beautifully from side to side with one support in the center, and it's a sort of structural finish. It drains through the middle, as I say, and it also forms your final walking surface. So doing many things all at once, inspired by the Pont des Arts in Paris, which has been there for a very long time, with a much thinner profile, but a hardwood deck. And this is we looked at a few different systems for how to integrate a slip resistance, because the trouble with timber, even a hardwood, is that it gets very slippery when it's wet. So we had to be sure that we had the right sort of gap for the draining and enough frequency of these slip-resistant resin profiles to get code-compliant slip resistance in wet conditions, especially because the bridge is on a camber, so you're then going downhill in the wet. And we needed to test all of this. This is the sort of color that the timber will weather to naturally over time. It's already begun to do that, in fact, a sort of silvery gray. You can see it here in the built condition, stainless steel, corten deck in the distance, and then these planks already beginning to weather on the bridge itself. So this was a big driver for the characteristic of the balustrade system, and that Network Rail are very anxious about people throwing things or themselves into the railway and stopping any rail traffic from happening. And their default is to do this sort of thing with their bridges. And we started the dialogue with Network Rail, and they said, you've got to absolutely cage over the top of your bridge. You've got to have a complete enclosure. It's got to be X meters tall and absolutely enormous, and that's the end of it. And we thought, well, if we basically asked the question, if we can demonstrate that we are adhering to all your criteria with a different solution, will you accept it? And they sort of grumbled a bit, so we took that as a nod, and then went down a long path of demonstrating that you don't have to have a cage over the top of your head, and that you can produce enough protection without doing that, because we were very keen to not lose the sense of the sky. And I think that there's a lot of security problems when you do put a cap on an enclosure. People don't feel very safe going down a route like that, so we were absolutely determined to, again, pursue to minimize this criteria as much as we possibly could. So just going back to this cross section, this is a typical condition of a balustrade, usually quite high on footbridges because people feel a bit exposed. It tends to be around 1.2 up here. You can lean on. They getting a bit nervous when it goes down to a sort of typical 900 to a meter. But what needed to happen over the railway, at least where we negotiated, is that in the most extreme case, it had to come right up to this height, which I think must be, I can't remember, I think it's near 3 meters. Sorry, and so rather than just boxing up over the whole length, we negotiated to have an eyelid shape. We agreed that we would go up to this height, but with having done that, we could keep this open to the sky. And what that means is that this is where the sense of this sort of scallop shape began to come into fruition. And because the bridge, not only on a camber, but also on a curve, so making the geometry quite complicated, means that you don't ever have that sort of long tunnel vision. It's a sort of emerging experience, and we modeled the bridge in 3D and checked that the sort of walking environment going along that, and convinced ourselves that it would feel really pleasant. And we were then very keen to be able to have a dense enough mesh so that people couldn't throw, I don't know what the criteria, 6 millimeter opening, so that you can't get anything significant onto the railway. Our mesh had to meet that criteria, but we could still see. So children come along, they get a long view of the railway, can see the train coming along, rather than reverting to a solid balustrade, which is what Network Rail's default is. Very important in terms of the experience of the bridge to get these things achieved if you can. So that's the character of that mesh. Now, another thing that came to light throughout the life was that we'd convinced them to have a completely open, well, I say it's completely open, but mesh-filled, but to have that level of visual link between all the way across. But halfway through the construction of this bridge, they came along and said, actually, We want to future-proof this bridge in case we go with overhead electric railway lines, and you need to make this balustrade system solid. So you can imagine that sort of thing coming and landing on the project at that late in the game when we're virtually building the thing. So it was back into heavy negotiation with Network Rail, and in the end we've got a compromise where there is a level, when you go and see it, of completely solid stainless steel panels to about this height over the critical width of the Network Rail. But we negotiated that they're on the outside of that mesh so that when you're on the bridge yourself, you barely perceive them. You get a long view, it's quite dense in terms of it, but they're out there to get Network Rail to be satisfied with that. We did mock-ups to test all this to make sure it was durable, and here you can see both what I'm describing in the built condition. It sparkles in the sunshine beautifully actually, but here you can just get a sight of those dreadful solid panels that we could not get rid of for the life of us. Just there for the maybe never needed, but just in case Network Rail have overhead railway lines. Just a little bit on landscape, because this is where it's not just the superstructure, the civils, the lighting, the drainage, but you tend to get involved in how these things land, of course, at either end. Two quite different conditions. Chiswick Park, very heavily manicured, business park on one side, and then a little bit of no man's land at the top end of Colonial Drive, which is a big residential development. And at this end, we had to integrate a lift because the levels were so high, driven by the clearance over Network Rail. We couldn't get down without taking the bridge, miles over here if we were going to use a ramp. So we had to integrate a lift for access and buggy users, and how to do that with a series of steps, and then long conversations with the police. Basically, this had to be compliant with Secure by Design. Very worried about rough sleeping under the bridge stairs. Very popular place for people to camp because they tend to be dry and untrafficked. So we ended up in a long debate about how to deter this, and ended up with a great big swathe of what's called defensive planting, which is basically very horrible prickly bushes which go all around the bridge here at the top end, right up against the London Underground fence, and a combination of horrible cobbles. So you can see this is the condition that we're trying to design toward. Sorry, I'm going to pick up my cobble drawing in a minute, but there's a sort of bed of glued in boulders so that people are dissuaded from trying to sleep under the bridge as well. So you have these sort of slightly crazy influences into your design all the time. On the stairs themselves, so you can see here, we decided to do a corten lift shaft as well, so a little baby corten building on the site. And then these important stairs. And what was, I guess, driving us here was that you had a sense of a generous journey. What you don't want to do, which often happens with footbridges, is you get to the end and you've got a sort of horrible little stair to get off what has been a very glorious journey over the primary span. This is actually the bridge at the British Museum, stairs at the British Museum project that I worked on while at Foster's, and this lovely sort of generous quality. So quite wide, I think they go out to 3 meters at this end. And then a conversation about regulation, which dictates that if you are a stair as wide as that, you must have a central balustrade. And we were reluctant to sort of congest the stair with that detail, and had a very proactive and lovely consultant working with us around disabled and what's sort of reasonable access for pieces of infrastructure, and we're able to convince the authorities that rail could go. So these little things that it's the constant, I suppose the lesson there is that you're given a lot of regulations and a lot of code, and it's always worth challenging, I think. If you feel you've got a convincing argument, just don't back down, especially if it's in the pursuit of less material or something which is more sustainable, something that has a longer life, or will in fact just be a more pleasurable scheme. And it's a good mindset. There it is under construction still, just finishing up on the podium. There's my tray of boulders that I was talking about. Surrounded by granite, a very uncomfortable bed with adjacent prickly holly bushes next to it. So let's hope no one chooses to, there they are, to populate that space. Just a tiny bit on the lift itself. It is a whole entire building. It's an internal lift, so the shaft had to undergo weather testing with a massive hose last week. So you actually get into a bit of proper architecture here. And it's just lovely to see the Kingspan panels arrive on site totally grey, and within a matter of hours they're already taking on this orange patina that you can see. This is in the process, with a very slender stainless steel lid to form a tiny little canopy over the entrance at deck level and down at the bottom. And here it's really, you want to sort of have a continuous camera watching this stuff. You can virtually see it converting to lovely orange. So it gets that sort of quality in its end condition. And the reality is that it's probably going to take about 6 years before the corten actually reaches its final pure orange. So it's going to be a long time coming, weather dependent. If it rains a lot, it will happen more quickly. Just finally on the lighting, also very important, another discipline that needs to enter into the frame. This was done with Spears and Major. And here, this goes back to the bats. The Gunnersby Triangle, very worried about light pollution over the top of the nature reserve, and we have to balance that against what feels safe as a user on the bridge. You're entering onto something which is 120 meters and you can't see the other end, and as a user you need to feel secure in making that journey, because once you're on it, you've only got 2 ways to get off. And that's very much in people's mind, and because it is open 24 hours a day, it's a gift to the public realm. It's not in any way managed or closed. You have to be mindful of giving enough security but not overwhelming these bats. And I suppose for us, it wasn't ever about being a big glory bridge. It was something which wanted to be fairly discreet in the landscape and be part of that tree canopy. So we were quite happy to not have a massive glowing arch. So what we've ended up with is a tiny bit of feature lighting which throws itself up the base of the arch, but then peters out quite quickly, so that this in effect sits in the dark of the tree canopies with bats happily living in and amongst it. But we have focused very much our efforts on lighting the deck. So the light doesn't come up except through reflection from the timber, and that's so that you don't get any glare in your eye line as you go along the bridge. So you in effect look into what is quite dark, but the surface is very clear and there's enough bounce back. And this is something that we test in computer modeling, but also on the mock-up, as to whether we're satisfied with that level. And what we've got are hundreds of, little, in effect, fairy spots in the underside, fairy light spots that sort of twinkle in the underside of that handrail. And that means that the handrail itself, a stainless steel tube, can act as a conduit for all the power lines, which come up the upright at one end, go the whole length of the bridge, feeding all these little lights, and then out the other end. And going back to vandalism, one of the drivers here was that the lights are out of sight, therefore people are less inclined to steal them. Have to actively get underneath the handrail, and they need a special tool to loosen this. And if you make it that much more difficult, you're hopeful that they'll stay there for longer. They're all LEDs, I should say, so they've got a very long life in the bulb and lower energy usage. Tiny bit of feature light on the underside of these little support legs, of which there are 3, but pretty low-key and pared back in terms of fittings. Those are the little lights set in the handrail, and these are the spots which throw a kind of cone of very specific light up the base of the arches. And a bit around the secure anxieties at this end as well. So just to end, really, I think that I don't know how much whether I made it clear enough, but the context of the bridge is such that it had to be, there was really no place to build it. There was no place to host a contractor, so it had to be assembled in a super small area immediately adjacent to the abutment on the Chiswick Park side. We managed to negotiate a few parking spaces over a period of time, and we could only build it in span by span. There wasn't even room to have multiple spans, so we had to fully assemble a span, lift it in this very tight window with everything on it. I mean, even the light fittings were on that bridge, so it's virtually wholly constructed, needed to get up in this 24-hour window. And this span weighs 90 tons. And what was quite incredible, they did it in the summer, as I say, it was a 24-hour shift. It started at 6 p.m. We all went down there and spent the whole night watching this thing happen. And what was amazing is this crane's driving around, and what they said to us is that the minute they lifted this off its temporary jig, which is this set here, they couldn't put it back down again. The whole thing was designed to sort of take a shape the minute it was lifted, and then all it wanted to do was go onto its legs, and it couldn't return to this jig, which sort of collapsed as they lifted the bridge. So it was a real sort of, there were a series of sort of stop points in the process, and the minute that they lifted that, there was no going back. So quite a sort of hairy night, but that was, so it went up in the middle of the night. It was just making its driving around, and it's moving toward the change in rotation with really quite kind of cartoon-like, couple guys at the end of ropes just sort of moving this thing around as it's swinging 90 tons over all of our heads and network rail. Got a bit caught up in the trees, which no one expected. Just a few moments with a chainsaw, and then it dropped. And there it is. In the morning, crane had to drive along this route here, having lifted it, carrying this 90-ton span, and it dropped in beautifully on its legs, ahead of schedule actually, which was great. And there we are that morning, drinking our tea, very happy, I should say, engineers, Charlie, Eva, George, Chris, and myself. And with that, I will stop. Sorry, no one interrupted with a question, but anyway. Yes, please, feel free. Yes, of course.
You were talking at one point about replacing the previous design of a concrete deck to a steel deck. And so the priority seemed to be about making it as light as possible. But don't you need the weight to hold it down?
Well, this was the dilemma, because it then got much lighter. But well, the concrete was in itself a walking surface as well as a spanning deck. So it was quite thick and heavy and did everything in one job. Then we reverted to the corten steel, which was very light. But then, of course, we needed a walking surface. And we did look at sort of bonded paint finishes on top of the steel to be super, super minimal. But in fact, there were maintenance concerns with that because it has to be reapplied. And also, we needed some weight back. But we found that we could control the weight of the timber more as a sort of more finessed control of the weight and distribution with the timber than we could with the concrete. So it was a kind of happy conversion from one to the other. Yes, and I suppose partly us interested in what you could do with the corten and also paring it back to just the three materials rather than having a fourth, which was the concrete. Yes, sorry.
How do you make sure that people don't find it?
Yeah, actually, it's a good, we had not only did we have to include these solid panels. Oops, sorry, this is quite a useful little drawing. But along the length here, between that cable which comes down and the plane of the mesh, there is a blade of stainless steel. So one of the uprights extends and grows a tail, which goes out and fills a gap, because there is, and I kind of can't believe we got away with it, there is a gap and a ledge, a natural ledge beyond the bridge deck and cables. Don't anyone get any ideas? So if you got yourself out there, you could sort of traverse along the length of this on a surface which probably feels quite safe, especially compared to the Millennium Bridge. But we then had to put this stop there. So this extended steel plate projects out, and in the end, they recognized that you could, if you were really, determined, sort of get around this plate and onto the other side. But because it is an obvious sign that you shouldn't go beyond it, that's enough sometimes. You've gone as far as you can at that point. So that's what we've done. There are two sort of long uprights of steel plate. So if you are traversing, you'll run into this panel. Good question, though. I forgot to mention that. Anything else? Yes?
I actually want to say something. Because all these the students that are here might be designing quite complex projects. Some of you might sort of go, well, I've got a bit of a little pedestrian bridge. You go, well, if you can design a pedestrian bridge with the degree of attention that was done tonight, you would pass everything that you need to pass. Because in a funny way, in architecture, I do want to bridge going to go fuck this forget the tennis? Line. How do you know the line? I'm interested how you know the life of a bridge or a building.
Well, I mean, in this instance, I think that there's confidence and evidence around the life of those materials. So corten has a long track record of performing very well for a long period of time, similar to timber and steel. So in their own right, they are okay, but it's the junctions and the connections and the fixings. Yeah, the cables. Well, they're stainless steel, and they've got they've got again a long life of performance. But so there is a maintenance regime, and you will over the course of I think it's 15 years. You might have to consider replacing some of the deck, but you can do it on each plank can be pulled out individually. So they've been designed to be mindful of not having to close the whole bridge or not for long periods of time, plank by plank. But the evidence, and there is a series of inspections that are required of the welds and the fixings, so there will have to be booked in points where one is able to inspect this bridge. But so there's a sort of 15-year cycle, there's a 20-year cycle. I didn't include the maintenance schedule, but that was quite important in terms of Network Rail and the client and Hounslow, who have now adopted this or will adopt this, anxieties about looking after this animal. But the sort of the depth of the weld and the design of the weld and the testing of the welds are such that they are high-performing welds, which should, sustain that life.
Who sets this 125? Where does that come from?
I don't know, because the Millennium Bridge was 100 years, and I don't know if it's defined by the Infrastructure Committee or the Institute of Civil Engineers. I honestly don't know. I don't know. I should know that. But yes, so on buildings it's the insurers or the yes. I mean, they tend to be.
Finances are happy if it fails after 100 well, if you paid off the mortgage.
Yeah, maybe. It is a long time.
Talking amongst ourselves.
Yes. No. I mean, it's. Anything else? Okay, my pleasure.